No clue how to fix a Mac? Swapping chips blaming me? Wasting your dive? Actually, you just need to understand this M2 system block diagram. It can instantly double your repair efficiency. Today, we're sharing it with you exclusively for free. The following video series will use the MacBook Air M2 model as an example to explore its repair methods and circuit principles with everyone, aiming to systematically organize repair ideas and principles. The M2 Society uses BGA packaging on a substrate area of 27.7mm by 24mm. It integrates as many as 2,581 pads. The diameter of these pads is 0.3mm, and the center spacing is 0.5mm. The diagram below clearly shows the specific location of the M2 Society on the motherboard. Regarding the display-related parts of this machine, all related circuits eventually converge at the display connector JP600. This is the specific location of that connector on the motherboard. Looking at the block diagram, the camera is connected to the main Society chip. Let's take the camera circuit as an example to talk about level shifting. The M2 Society is 1.25 volts, and the camera is 1.8 volts. This requires level shifting, but interesting, not all lines require a conversion chip. For example, these two differential data lines can be directly connected through capacitive coupling. And this interrupt line is an open drain output, which a pull-up resistor can handle. However, something like the I2C bus must rely on a conversion chip like the UD120. Actually, this kind of design provides excellent protection. When the camera fails, these circuits can effectively isolate voltage and current, preventing the expensive Society from being burned out. The camera connector is located to the right of the display connector. JT201 is quite interesting. This is the daughter board. It connects to JT201 via a ribbon cable. This daughter board provides extended connections for the keyboard backlight, fingerprint button, screen, angle sensor, and the headphone jack. If there's a fault in the ribbon cable or related circuits, it will cause the corresponding functions to fail. This is the location of JT201 on the motherboard. GT400 is the interface on the motherboard, responsible for connecting the trackpad. Various power supplies will first pass through the corresponding electronic fuses and then power the trackpad through this interface. Let's take a look at its specific location on the motherboard. This area is responsible for audio signal processing and connection. There are three key connector interfaces distributed here: the left channel speaker, the right channel speaker, and the microphone connector. Next, we will locate them one by one on the motherboard. Let's focus on the storage core part of the motherboard. First, let's look at the SSD chips. UN000 and UN100 are the NAND flash chips. As you can see, this 256GB, the base model only has the UN000 chip installed. If it's a 512GB or higher capacity model, 2 chips will be installed. Here's a key point. The read and write speed of a single chip is nearly twice as slow as 2 chips. Of course, this can be solved by expanding capacity later. In the future, we'll make a dedicated video to explain this in detail. Next is the encryption chip, U1950. It's encrypted and bound to the SoC and the computer's main hardware. If the data inside is lost or the chip is damaged, this computer will lose its repair value. Therefore, you need to be extra careful during repairs. Finally, there's the boot flash memory, U1900. This is a flash memory chip with an SPI interface. The computer's lowest level boot code and initialization programs are all stored here. Once its program is lost or the chip is damaged, the computer will not be able to turn on. So this is also a chip that requires significant attention. UL000 is the Wi-Fi and Bluetooth 2-in-1 module chip. This is its location on the motherboard. There are 2 coaxial antenna sockets on top. Please note that this chip has been officially bound and encrypted. It must first be unbound, using professional equipment before replacement. A UE400 integrates a 3-axis accelerometer and a 3-axis gyroscope. A 5000 is a chip used for encryption authentication. This is the UE400 check. This is the U5000 chip. In daily laptop repairs, over 75% of faults are power-related. Now, let's explain the various power-related parts. This model is equipped with 2 USB-C ports and 1 magnetic connector charging port. Both USB-C ports support Thunderbolt 3 and USB 4 protocols, and both can be used for charging. Their circuit principles are basically the same, and they are independent. We'll use the first USB-C port as an example. F400 model CD3217 is a PD controller customized by TI for Apple. It handles transmission, identification, and negotiation of the USB PD protocol. This chip has a built-in bidirectional power switch. Whether it's charging the machine or providing external power, it must be switched and managed through this chip. Therefore, it's a core chip that requires significant focus during the repair process. UF000 is the Thunderbolt interface chip, responsible for high-speed data transfer. UF600 is the USB low-speed interface level shifter. Here, I'll emphasize that USB 0 has one more low-speed debug interface function than USB 1. Please note this difference in their circuit design. This is exactly why USB 0 supports DFU flashing, while USB 1 does not. Please pay attention to identifying this during repairs. The magnetic charging port also uses the CD3217 chip for power switching and management. The connectors for USB 0 and USB 1 are JE700 and JE701. The magnetic charging interface is J5401. UF400, UF500, and U5500 are PD controller chips. Please note that U5500 controls magnetic charging. Let's look at the transmission part. UF600 is the level shifter for the USB 0 port. F650 is the level shifter for the USB 1 port. What enables high-speed connection for both USB ports is the Thunderbolt chips located here, UF000 and UF100. Power comes from the USB or magnetic charging port and is first sent to the battery management chip, U5200. This chip is very powerful with bidirectional buck boost capability. In this machine, it mainly handles 2 core tasks. 1. Generating the common point voltage. 2. Managing the charging of the 3 internal lithium batteries. A special note, when you open the back cover, you will see 4 battery cells, but the top 2 are connected in parallel. Therefore, the battery pack's output voltage is still that of 3 cells. This is the specific location of U5200 on the motherboard. This is the battery connector, J5150. Before starting any motherboard repairs, you must remove the battery plug from this connector to cut power to the board. 5700 converts the common point voltage into the 3.8 volt main supply. This is an important power conversion chip. The current of PP3V80N is up to 30 amps, mainly powering the power management chips. The 5 volt conversion is handled by the UC300 chip. The 5 volt power provided to peripherals via the USB port also comes from here. The core of the system's power supply is the U8100 power management chip and its collaborating sub-power management chip, U7700. The two communicate via the I2C bus, providing various power supplies to M2 functional modules in strict accordance with the PMIC. Additionally, some chips are powered by 3.3 volts, where UC710 converts the common point voltage into PP3V3S2. Let's look at the specific locations of each power chip. 3.8 volt main power chip, U5700. 5 volt power chip, UC300. 3.3 volt power chip, UC710. Main power supply chip, U8100. Sub power supply chip, U7700. That's all for today's sharing. Follow me to unlock more expert knowledge on Mac repair.